All right, so today let's look at yesterday's homework. Was page number 19? What page was it? 21. Nope. 19 is correct. That's what I said to turn to. So page 19. Here's what you should have done. I helped you a little bit in class. It says the ratio is 3 to 5. And if you did 3 to 5, you could also do 6 to 10, but then you could also do another one, whatever. I did 3 times 3 and 5 times 3 to get to 15. Okay? Now, is there a same number that is multiplied to all of them? It's kind of a weird number, a little bit different number. In this case, it's actually 5/3. And how do we figure out that that number is 5/3? Well, you reverse. So what am I doing from here to here? I reverse it. What's 5 divided by 3? 5/3. What's 6 divided by 10, or the fraction 10/6? Reduces down to 5/3. Same thing here. So that is proportional situation, and our K value is 5/3. Okay? And kind of the cool trick here. What is 3 times 5? 15 divided by 3, 5. What's 6 times 5? 30 divided by 3, 10. What is 9 times 5? 45 divided by 3, 15. So it checks out. Okay? So actually working with fractions is not that bad if you know some tricks. I hope to show you some tricks this year. Okay? Next one, John, he's a busy guy. He's filling a bathtub with some water. Needs to have it 18 inches. Okay? Now he notices that it took 2 minutes to fill it with 3 inches of water. He estimates or thinks it will be full or take 10 minutes to get up to the full mark, which is 18 inches. So now, I told you this yesterday, sometimes they give you a table, sometimes you got to make your own. The two things that we're worrying about here are how long did it take, time, and how high is the water level in the tub, water height. Now, the water height, how much water is in there, depends on how long you've been running the water. Does that make sense? Right? So yesterday we talked about that relationship. We're going to talk about it more today. We know it's 2 minutes. You get 3 inches. So if we double both of those, 4 minutes gives you 6 inches. I could double that. 8 minutes gives you 12 inches. But then to 12, what did I do to 2 to get to 12? Times 6. What did I do to 3 to get to 18? Exact same thing. That works. But also watch this trick. If I had 4 inches or 4 minutes and 8 minutes, how many total minutes would that be? 12. Then it says, well, this would be 6 inches of water. That's 12 inches of water. Those add up to 18. See how that works also? So there'll be a couple different ways you can find this out. And it is correct in his assumption. After 10 minutes or 10 minutes more, he would have 8 inches or 18 inches of water there. That make sense? Okay. All right, so now let's flip in the book to lesson 3. And I took the liberty of writing this down beforehand. Let's have you write it down. Yesterday we talked about dependent variable and independent variable. I won't always write the variable there, but we're talking dependent variable, independent variable. If you just write dependent, independent, that's probably good enough. But again, anything that is written down that's not already in your book, what do you think you should be doing? Writing it down in your book. Good. So you have been hired by your neighbors to babysit their children on Friday nights. You're going to be paid $8 per hour. Now, when we had babysitters for our kids many years ago, the rule of thumb was it was $2 per kid per hour. So we had 3 kids times 2 times, if 1 hour, it'd be $6. What if it was 4 hours? $24, right? And if I was nice and the kids were maybe naughty or whatever, maybe I'd pay $25. Or maybe if they did fun stuff with them and I knew they're doing whatever, crafts or whatever, I might pay $30 an hour. So here's the deal. This is a different time. I don't know if it's the same rate or if maybe they had 2 kids and it's $4 per hour. Or maybe it's just a flat $8. Okay? Who knows the details there? But it could be some kind of behind the scenes stuff. Now, what I want you to do is complete the table. But first, though, what is the dependent and what is the independent? What variable, I'll even give you 2 guesses. What variable tied to the dependent variable? What one was that? The X or the Y? Yes, Cal? X or the Y? I'll give you 2 guesses. I'll give you another guess. Y is correct. The dependent variable is the Y. Okay? The dependent variable is the Y. The independent variable is the X. And remember what dependent means. It means you depend on other people. Yes. Yeah, that is just that. When you were little, and even now, you're still dependent on your parents, right? You're dependent on them to get food to the house. You don't have to go out and buy groceries. Maybe you help with that. They're moving you more and more towards being independent. Okay? Little Hayes at home, he is totally dependent on us. He can't have anything done unless we help him. Unless it's pooping and potting. He's got that down pretty well. So here's the deal. This ties to an equation that we wrote yesterday, which was y equals, what was that new letter we introduced? K times x. And notice how I wrote the K. It's cursive, so it doesn't look like a 1 is less than. Right? That could be confusing. We're going to do a K there. And what did that K represent? What was that big phrase that's sometimes hard to say? Constant of, and I'm going to start here, proportionality. I do pro-por-shun-al-ity. Constant proportionality. Now, another name for that is a unit rate. What is the unit rate? Sometimes you know it, sometimes you got to figure it out. Later on, they're going to change it, and I don't know why it's a K and not a C. I don't honestly know. I should Google that. But later on, you're going to see equation forms that look like this. Y equals mx plus b. It's a little more complicated, but we're setting you up for that, getting you ready for that. Okay? So here's the deal. I want you to fill in a table now. If you worked 1 hour, how much do you get paid? $8. Here, last year I made them label dollar signs. We're just going to put dollar sign there. We know it's dollars. We know this is the Y. We know this is the X. You could pick any random number of hours and figure out how much you get paid, right? That's what the X kind of lets you do. You can pick whatever you want, figure out what it is. Now, as you go down, easy, but this one's kind of tricky, and the bottom one is kind of tricky. So leave those. Do the whole number hours. Fill those in. You got about 7 seconds. Oops. Okay. Did you get those all right? Now, these are kind of tough. Well, what do you know about 4 and 5? What's exactly in between 4 and 5? 4.5. So what's exactly in between 32 and 40? 36, right? So it's 4 up and 4 down to 36. You could do this off the side. I'm going to show you some tricks this year. This is one trick that you can use a lot. I did 4.5 times 8. Here's what you do. What's 4 times 8? 32. What's half of 8? 4. What's 32 plus 4? 36. Down here, 6.5. We can do 6.5 times 8. In your head, you can do this. What's 8 times 6? 48. What's half of 8? What's 48 plus 4? 52. Right? Good. Now, here's the deal. We want to double check this. What I want to do is find the unit rate. We said that's kind of like the constant. It's exactly like the proportionality. So what we do to find that unit rate, we did it with our hands. We do dollars divided by, in this case, time. What you get. This is how many hours do you get. So notice now we can put dollars per hour. This would be like time, or we could do hours right there. We looked at miles per hour. That is horrible spelling. That's hours right there, okay? Overlapping a little bit. Dollars per hour. So let's check right here. If you had $48 divided by how many hours did you work? Is 48 divided by 6 equal to 8, which is that unit rate. Is that correct? Yeah. We can sometimes look at this too. It's going to be whatever your Y is divided by your X. Okay? It's the same thing there. And it ties again. What am I doing to X to get to Y? What am I doing to this right here? Well, I'm multiplying by whatever K is to get to that. What was our K value in this again? So our equation would be y equals 8x. What am I doing to the x to get to the y? Times it by 8. Perfect. And if we can't see that, sometimes it's not as apparent. What we can do is reverse the order. I take y divided by x, and that gives me that k value every single time. Okay? Now, this one was totally proportional. Why was it totally proportional? Because there was a k value that was constant. Okay? So this was proportional. Is it? Yes. That's a horrible yes. Why? Because k equals 8. If there were different k values, guess what? Not proportional. If that is the same going from every x to every y, then it is a proportional relationship. Now, what if you babysat 0 hours? How much money do you get paid? $0, right? And that's, again, an important piece of the puzzle. We're going to see some problems where that's not the case. And if it's not the case, it's not proportional, right? If you don't have a 0, 0, it's not going to be proportional. Okay? All right, next page. This one too, there's 3 parts. We're going to go check proportionality. Again, I think it helps for you to think about dependent and independent. Click on the pen, there we go. So let's write dependent again. Dependent and independent. And we're just going to check and see if these situations, if these tables are proportional. Checking for proportionality. Now, the first one says table below represents a relationship of the amount of snowfall in 5 counties to the amount of time that went elapsed while it was snowing. So this could be like Buffalo County, Dawson County, Phelps County, Hall County, whatever county. Okay, 5 different counties. In 2 hours, it snowed 10 inches. Okay. Now, what depends on what? Does the time that goes by depend on how much snow there was? That doesn't make sense. Time depends on nothing. The snowfall, the amount of snowfall that fell, does that depend on how long it snowed? Yeah, the longer it snows, the more snow you're going to get, depending on how heavy the snowfall is. But it's over these counties. So this is your dependent. This is your independent, right? Y and X. The amount of snow you get depends on how long it snowed. That make sense? Okay. So now, what is my constant proportionality? What am I doing to the x value to get to the y value? Well, in this first one, 2 times what is 10? 5. So that's times 5. Okay? What about the other county? 6 times 2 is 12. So this one's times 2. Now, here's the deal. You could stop right now. They are different. There is not a constant proportionality. So this one would be not proportional. And we could say there are different values of k. But here's the deal. I'm not always going to make it that easy. I might make it so the first 4 or 5 all are the same number, and it's the last one that's messed up. So here's the deal. You need to check. Did I multiply 8 times something to get 16? Yeah, times 2. What about 2.5 to 5? Times 2. What about 7 to 14? Yeah. Times 2. So all these other ones are times 2. But if you have one that's wrong, the one that's different, it's not proportional. Sometimes I leave it for the very last one. Then sometimes I put it like in the middle. You got to check every single relationship to make sure it's the same. And if there's any differences, it's not proportional. If they were all the same, yes, proportional. Does that make sense? Mm-hmm. So in this situation, the snowfall is not proportional to the time. Okay? What about the next one? It says table below shows relationship between the cost of renting a movie. You guys rent movies anymore?
Yeah.
I used to do it from Blockbuster here in town, and then that went away. And then we'd buy a lot of movies and DVDs. And then we started renting some DVDs from like a Redbox, but I haven't done that probably in years. We do it digitally. But we still rent them, and they disappear after like 24 hours after you watch them. Back in the old days, you can go in and rent a movie, a VHS, a DVD, and they'd say, all right, you get to keep it for 3 days. And we look here, that's the situation, okay? Now, again, which one's dependent, which one is independent? Does it make sense that the amount you pay, the cost, depends on how long you rent it? Doesn't that make sense? So yeah, this is our Y, and it's going to follow, we're going to see, does it follow this pattern? Y equals K times X. Now, what I want to know is what am I doing to the X to get to the Y? What am I multiplying by X to get to the Y? Now, don't be tricked. What am I multiplying by X to get to Y? Jackie. Oh, you're hesitant because you noticed something. Are you multiplying by something? No. Well, here's the deal. You tell me, hey, Mr. Sandy, all these are dividing by what?
3.
They're all dividing by 3. Okay? We're going to see this a lot more. Maybe you saw a little bit last year. But dividing by 3, there's another way you can write it. Okay? Let's go back to stuff we know. What's the opposite of adding 5? Subtracting 5. What's the opposite of subtracting 9? Adding 9. Those are opposites. Well, with multiplication and division, they're not opposites. They're called inverses. When we divide by 3, that is the same as multiplying by 1/3. Okay? Let's verify that. What is 6 times 1? What is 6 times 1? 6 divided by 3. 2. What is 9 times 1? I'm multiplying just straight across. What's 9 times 1? 9 divided by 3. 3. What is 24 times 1? 24 divided by 3. 8. What is 3 times 1 divided by 3? 1. Okay, so the rental amount is for $1, you get 3 days of rental. Is that consistent the entire time? Yes, so this one would be yes, proportional. Proportional. And why? Because K is always equal to, in this case, 1/3. Okay? Could you rent a video for 1 day? No. Oh, they don't have that. They used to. It was like 1 day, and then people were turning them late all the time because we couldn't get in. They said, all right, you got 3 days. You can return it early if you want, but you have 3 days. And if you don't return it after 3 days, you pay late fees. Okay? But you can't have it for 1 day. You can't have it for 4 days. You got to pay for 3, 6, 9, 12, so on and so forth. All right? Next page. This table shows the relationship between the amount of candy that you purchase in pounds and the total cost of candy in dollars. Have you ever been to the bulk candy stores at malls or other places, which I don't know how they're doing it now. But those places, think of that. They had it probably shut down. You couldn't buy bulk candy. You can't go serve yourself those candies anymore. I wonder. I'm nervous about those. I hadn't thought about that until this problem showed up. Okay? Now, does it make sense? The amount of money you pay depends on how much you get. Yeah. The amount that you get does not depend on the money. Although if you only had $5, you got to be very careful. I know when I've taken my boys into those stores, I've hated it because they just load those bags up, and then it's like 40 pounds of candy in that one bag, and that's very expensive. This is actually a pretty cheap candy store. But what we want to do and check, what am I doing to the X to get to the Y? Is it the same? You're looking it over. Is it the same every time? And what is that thing you're multiplying by? 2. Are they all by 2?
Yeah.
You got to check every single one. Okay? Every single one. I might make it the last one that's not right, or maybe one in the middle, and then it's not proportional. So, yes. And simply, we've been wordy before. We can just say K equals 2. Okay? Simple enough?
Yes.
Good. Now, Randy, he's doing a little road trip. He's planning to drive from New Jersey down to Florida. Every time Randy stops for gas, he records the distance he traveled in miles and the total number of gallons he used, which my dad used to do this. I remember my dad had a little notebook in the car. He'd record this. Now, cars are smart enough. Guess what they do for you? They keep track. The new cars do that. My truck doesn't do that for me. But you can, the vehicles now tell you that stuff. Here's what we need to find. We need to find the unit rate. Okay? When we find the unit rate, then guess what we can do? Fill in the blanks. And in this case, the unit rate, well, this one is kind of confusing. Are the gallons you use dependent on the miles you drive? Kind of, but how far you drive depends on how much gas you have, right? If I don't have any gas, can I drive any miles? No. So here's the deal. We're going to assume that the gallons of gas are unlimited. And we're going to say this miles driven depends on how many gallons you can buy. Okay? And then we could look at the factor of how much you're paying per gallon, but we're not worrying about that right now. Okay? So now we're going to take, in this case, miles that you drive per gallon. How many miles can you go on 1 gallon? Now, can you see that number? Yeah, you can see it easily here. What about this one? This is the one that he said. Let's look at this. The miles he drove was 216 miles, right? And how many gallons did he use? 8 miles per gallon. Go to your calculator. Miles per gallon, 216 divided by 8. And again, why do I say go to your calculator? Some people sit there and don't do anything. I'm trying to give you practice on the calculator. I'm trying to give you confidence when you get to the test and you need to use a calculator of what you're doing. If you never get out a calculator and do what I ask, what you're supposed to do, when you get to the test, you think you're going to have much success on your own.
No.
Probably not. Alyssa, what'd you get?
27.
Perfect, right? And you probably could have seen that right there. So this would be 27 miles per gallon. Notice I didn't spell it out because it's right there, right? So we can abbreviate it there. That is our unit rate. That is our K value, right? So our equation would now be Y equals, which is our miles, 27 times, well, how many gallons did we use? X. So on every one of these, what am I going to do to 2 to get to 54? Times 27. Does that check? Now, if I know I use 4 gallons, what do I do to get down to that? Times 27. What's 4 times 27, Jackie?
108.
108, which I can do in my head. What's 4 times 20? 4 times 20 is 80. What's 4 times 7? 4 times 7 is 28. 28 plus 80 is 108. Uh-oh, they gave us this one. Now, I don't know what we're doing here, but guess what? I can go back the other way. What's the opposite of multiplying by 27? Dividing by 27. So go to your calculator, 189 divided by 27. Jackie? 7. This one we verified. Do you need a calculator on this one? I know I used 10 gallons. 10 times 27 is just 1 times 27 with a 0. And then 12 gallons. Yes. 324. Now, you can use your calculator. You can multiply by 27, but watch this. I know 12 gallons is the same as 10 gallons and 2 gallons. Does that make sense? Right? And 10 gallons was 270. 2 gallons was 54. I'm going to add those two together. Now, how far is 270 away from 300? 30. What I'm going to do is slide $30, so to speak, from this pile to that pile. When I take 30 away from that, what's left? 24, and that was 300. We can get it that way. So there's a couple different ways you can do it. Okay? And now let's say, hey, he used like 87 gallons of gas. How far did he drive? Well, we just put 87 right there. Super easy now that we have a formula. And again, this one is proportional. We said it is proportional. If he drove 0 miles, how many gallons did he use? Yeah. If he had 0 gallons, how far could he go? 0 miles. All right. So that's an important piece of the puzzle. So now this is a very wordy way of what we just talked about, of the relationship and how to figure out if it is proportional. This is kind of a key thing. You're going to take whatever your y is, that dependent variable divided by the x. Okay? That is a way to check. And that tells me what am I doing to the x to get to the y. Yes. Okay? So we divide that out. Now, next page, don't worry about the exit ticket yet. So we're going to skip the exit ticket. We're going to go to your the homework helper. And what are you going to do with the homework helper? Read through it. This would be I like this page, getting ready for the test, which is a week from tomorrow. Although I might change that. Me and Mr. Sandy might make it Thursday. We'll check what our schedule is. But look over this, read over it. Does it make sense? Your homework starts on the problem set, which is page 29. And for this one, you're going to do 1, 2, 3, 4, 5. Notice 4 has an A and a B, so you're doing those. And you're skipping 6, but you're doing 7. You might be circling these so you know what you're doing. And then 8 on the next page. So basically, 1 through 8, not 6. Okay? Do they give you a lot of room to write and do your work? No. And that's one thing I wish they would fix. But they do give you some room down here. They do give you some room on this side. Maybe you can use this and this right there. So for tomorrow, a little bit of homework. 1 through 8, not 6. Look over your homework helper. Makes me hungry. And you should be good.